At the end of World War II, the Allies were reeling from a battle with Germany and Japan, but they had to quickly retool for the new Cold War threats that lay ahead. Instead of contending with the Luftwaffe and Japanese forces, they had to keep an ever-vigilant eye on the skies for Soviet bombers loaded with nuclear weapons. New advanced jet aircraft were desperately needed to keep the Soviets in check, but none were ready. The Allies would turn to old warriors to defend, while aircraft manufacturers raced to build the next generation of interceptors. The atomic bombs dropped on Japan in World War II brought hostilities to a sudden end. While the world celebrated, the military planners of the world braced them for the possibility of an atomic war. Whoever controlled nuclear weapons held the key to global power or global destruction. The Soviets, once an ally, cloned the deadly B-29s that had rained nuclear destruction upon Japan. Soon Stalin would have his own atomic bombs and fleets of aircraft capable of lashing out at his enemies. Like Hitler before him, he was anxious to expand his borders. At first, Britain and the US turned to aircraft from World War II to guard the skies. The Mosquito, the wooden wonder of World War II, was kept in service to patrol for invaders. At one time one of the fastest aircraft in the world, it also made a reputation for itself as a night fighter. With radar installed and a radar operator on board to pinpoint targets, the Mosquito night fighters made quick work of enemy German bombers. A solid two-man crew was essential to the success of a night fighter, says RAF pilot Tex Jones.
The two-man crew is better for the identification. A lot of the work in air defense is identifying a target in the dark or in cloud. And if the target's evading, then you're better with a two-man crew for that if you've got a good team. If you haven't got a good team, you might actually be worse off.
As successful as the Mosquito was, technology was quickly changing. To keep it from becoming a museum piece, at war's end the Mosquito was retrofitted with better engines and new American radar. Like Britain, the US relied upon an old warrior to defend its night skies against Soviet attacks. The Northrop P-61 Black Widow rolled off the assembly line in October of 1943. Its pilot, gunner, and radar operator worked in tandem to fight off German and Japanese threats. The Black Widow was the first aircraft purpose-built to use radar, which made it ideal for night missions or flying in bad weather. Though the few Black Widows that went into service proved to be effective night fighters, by war's end they were already near or at obsolescence, lacking the range and speed to compete with new aircraft. Putting the Black Widow and Mosquito on guard against a Soviet sneak night attack was an act of sheer desperation. If Soviet bombers came across the channel, it was doubtful that these piston-powered aircraft would be able to reach them in time to make a difference. But they were the best aircraft available for the job. New interceptors built for the new realities of the nuclear age and jet age were a top priority. It was only a matter of time before Stalin's scientists unlocked the secrets of the nuclear bomb. Just as the first of the Soviets' Tu-4 Bull took to the air, the Air Ministry put out a specification for new all-weather night fighters for the Royal Air Force and the Fleet Air Arm. The Royal Air Force was looking to replace the Mosquito with a jet-powered, swept-wing aircraft capable of flying in all weather conditions and at extreme altitudes. In other words, they needed an aircraft to hunt down the Soviet Bull. The Royal Navy was looking for a similar aircraft with the additional requirement that it could operate from a carrier. The Gloster Aircraft Company was eager to submit designs for the RAF specification. At the start of the war, they had no modern designs of their own, and continued to build biplanes like the Gloster Gladiator. Though seemingly behind the times, Gloster took a giant leap ahead of all aircraft manufacturers around the world. They would build the airframe for Britain's first two jet aircraft, the prototype E-2839 and the twin-engined Gloster Meteor. Aircraft manufacturer de Havilland too had expertise in jets, building Britain's second fighter, the nimble Vampire, powered by their Goblin engine. They also were ahead of the curve in swept-wing technology. Extensive experiments were underway of their swept-wing airliner, the de Havilland Comet. Gloster and de Havilland were both awarded contracts to develop prototype aircraft to satisfy the ministry specifications. Gloster went to work on the Javelin for the RAF, while de Havilland developed the Sea Vixen for the RAF and Royal Navy. The Javelin and Sea Vixen were to be advanced jet fighters, capable of taming the Bull or other Soviet aircraft, but they were still years away from flight, and the Soviet threat was intensifying. In August of 1949, the Soviets detonated their first atomic bomb, the RDS-1. Stalin was in the nuclear club, and it would only be a matter of time before the Soviets perfected a system for delivering and dropping the bomb. Faced with an emergency, the British again turned to an existing aircraft as a stopgap measure, the Gloster Meteor. Gloster already had a two-seat version of the Meteor meant for training pilots, but with some modifications and extra equipment, this trainer was quickly transformed into a night fighter. The nose was redesigned and extended to house radar for detecting enemy aircraft. Instead of an instructor and student, Gloster's new night fighter carried a pilot and navigator. The first prototype flew in May of 1950, and improved production models would follow with additional upgrades. In weapons tests, the Meteor night fighter also carried a deadly antidote to Soviet bombers, the Fairey Fireflash, a radar-guided air-to-air missile. The Fireflash was propelled by a pair of booster rockets, which separated the moment after launch. The deadly missile then coasted to its target, following a radar beam projected from the aircraft and aimed by the pilot using his gun sight. Across the Atlantic, the Americans were equally anxious to build aircraft to repel a potential Soviet nuclear attack. Early on, they had gambled on the Curtiss-Wright XF-87 Black Hawk, but they were unimpressed with its capabilities. The F-89 Scorpion was a much more promising interceptor. It was a straight-wing, jet-powered, all-weather aircraft. Later variants of the Scorpion had a deadly sting, a salvo of folding-fin Mighty Mouse rockets mounted on the wingtips. As with the Fireflash, it was hoped a blast of these air-to-air rockets could bring down a Soviet bomber. Colonel Charles McGee recalls flying the Scorpion.
The F-89, which was quite an interesting aircraft with big rocket pods out on the end of the wing. Pretty heavy aircraft, but as the usual case that we've done in so many of our aircraft, by the time we get through hanging things on them, they're all underpowered. And the F-89 didn't last long, but it was one of the airplanes in the air defense development that took place as we moved into the Cold War time frame and our expectations that we might have to fight Russia.
Though the Scorpion's first flight was in August of 1948, it would be another 2 years before the production versions were combat ready. The Americans needed a temporary fix while they waited for the production Scorpions to hatch. The USAAF turned to Lockheed for help, and Lockheed in turn took a page from Gloster's playbook. Lockheed already had a capable two-seat trainer with Shooting Star. With the Cold War reached a boiling point. The Korean conflict saw fears of the communist expansion and the Soviet threat become a bloody reality. It was a testing ground for new night fighters like the Scorpion and Starfire. With the world's nuclear powers sparring with each other, it was unclear if hostilities would expand and escalate into a nuclear conflict. While the Soviets and Americans vied for control of the Korean peninsula, Britain was nervously watching her borders for a potential Soviet attack. Gloster and de Havilland hurried development of their prototypes. The de Havilland Sea Vixen first took flight in September of 1951. Like the de Havilland Vampire, it was a twin-boom fighter. The Vixen carried no guns. Instead, it relied upon an awesome arsenal of rockets, missiles, and bombs, including 4 de Havilland Firestreak air-to-air missiles, 2 microcell unguided rocket packs, and 2,000 pounds of bombs. Though a formidable aircraft, the Navy by this time had decided on the Sea Venom for its needs, a decision it would reverse in just a few years as the Vixen came of age. Test pilot Captain Eric Brown recalls his impressions of the Sea Vixen.
Basically, good night fighter. There were 2 aspects to it, which weren't very good. Pilot's point of view may be that it was all right as an airplane, but what did the observer think? He was in a coal hole on the right of the pilot, and he was completely enclosed in there. And he hadn't much idea of what was going on outside. I would think it was a most unpleasant experience to be an observer on a Sea Vixen. And also, unfortunately, night landing, deck landing is never easier. Well, a big airplane like this, it had the sad fault that the ailerons became very ineffective at the low speeds at which deck landing are carried out. And this caused problems with lining up the aircraft with the center line of the carrier at night. And the Vixen acquired a rather unfortunate accident rate.
The Gloster Javelin took flight 2 months after the Sea Vixen. It was hoped its delta wing and large T-shaped tailplane would make it more maneuverable at high speeds, while allowing it to land at slower, safer speeds. The initial production FAW-1 version was powered with Armstrong Siddeley Sapphire SA-6 engines with 8,000 pounds of thrust. The Javelin had 4 30mm 8-inch cannons in its wings, designed to tear into the shells of Soviet aircraft. RAF pilot Tex Jones had an opportunity to fly the Javelin.
The Javelin was not a complicated airplane. It was a very old airplane. It was all done with doll's eyes and things like that rather than modern electronics. The Javelin wasn't a high-performance aircraft. The Javelin's forte was as a night fighter because it had a 2-man crew. And its strength came from the fact that it had 2 radars. It had a B scope and a C scope. And the B scope was a conventional radar that just gave you a horizontal plan of what was going on. But the C scope gave you a vertical picture as well. So you knew where a target was vertically as well.
With 2-man crews, teamwork was essential to the success of the missions.
We flew as constituted crews. You worked up through the conversion unit with a navigator, and you flew with him the whole time unless he was sick. And you did develop a very good rapport. And we would track evading targets at 250 feet in the dark at 250 yards range, purely because the chat from the guy in the back was good enough to allow you to do that.
Soviet aircraft designers did not sit idly by as hostilities intensified between the East and West. They continued to produce new, faster and deadlier aircraft, like the Bull's successor, the Tupolev Tu-95 Bear. This massive intercontinental bomber was designed to carry nuclear weapons, including the largest weapon ever detonated, the Soviet Tsar bomb. During the Cold War, the high-flying Bear was one of the Javelin's main adversaries. The stakes were high. In a full-blown nuclear war, each bomber that escaped through Britain's defenses might exterminate the population of an entire city. The Javelin slowly took over the responsibilities from the Meteor, watching over the night skies of Britain, its bases, and other interests around the globe. Year after year, the Javelin and its crews probed the night skies for any creeping invaders, but none ever came. Though the Javelins never had to face a Soviet attack, they were deployed to several smaller conflicts around the globe, including one which could have seen them facing off against British-made Hawker Hunters. When Rhodesia declared independence in 1965, Britain put heavy economic sanctions in place as the Rhodesians had violated Britain's policy of no independence before majority rule. It was feared that Rhodesians would shut off power at a hydroelectric dam on their border with Zambia as an act of retaliation. The power plant was key to Zambia's copper mining industry. Rhodesia was already armed with Hawker Hunters, and the Javelins were sent in to equalize the odds. Javelin pilot Tex Jones was sent into similar tense situations in Borneo and Hong Kong.
The Javelin in those days was really only being used in the Far East, mainly in Borneo for the insurgents there, and it was used mainly as artillery, because when you plugged the reheat in and out in the Javelin, it made a big boom, and the communists, we used to fly up and down sort of 5 miles behind the front line. The communists thought we had artillery. We went to Hong Kong when the riots were on in '67. The Chinese thought when the RAF pulled out of Sekong, the Hunter Squadron, 28 Squadron, that it was the Brits sending Hong Kong back to them. So they were making noises about coming down into Hong Kong. And we were spending 3 weeks on, 3 weeks off in Hong Kong. We'd spend half of the time with the fuel tanks off, the underwing fuel tanks off at high level, doing combat just so we could be seen by the Chinese radars. And the other time, the rest of the time was spent at low level, just blasting around low level, just making as much noise as we could, letting people know that we were still there.
Soon the Javelin, like the Meteor and Mosquito before it, reached retirement. By April of 1968, the last squadron was disbanded, and more sophisticated interceptors took its place, ready for the challenges of the present and near future. The Javelin was replaced by the English Electric Lightning, a single-seat Mach 2 interceptor with navigation and targeting in the hands of the pilot. Javelin pilots were not handicapped transitioning to a single-seat interceptor. Their experience working with a navigator gave them an edge over other pilots.
Having had a navigator made it easier as a single-seat guy because you had the background of knowing the geometry of intercepts and things like that. Because we call it the God's eye view. You've got to be able to see an intercept from above. You've got to be able to see the geometry of it. And if you can't do that, you're never going to be able to do the job.
The threat of a Soviet attack forced the Allies to innovate and create a slew of interceptors. Though the Javelin never faced a Soviet bomber in combat, it did serve as an equalizer in the arms race, keeping the Soviets in check and minimizing the chances of a nuclear attack.
On the 14th of October 1947, Captain Charles Chuck Yeager of the United States Air Force climbed aboard his Bell X-1 aircraft slung beneath the B-29 Super Fortress. Following his release, he leveled off at 40,000 feet above the Mojave Desert and fired the third of the aircraft's 4 rockets. Initially, the ride was rough and control almost non-existent. Then, as he neared the speed of sound, Mach 1, the ride smoothed out and control was regained. Quickly, the needle went to 1.02, paused several seconds, and then jumped to 1.06. And that was it. Chuck Yeager had earned his place in history as the first man to pierce the dreaded sound barrier. Although news of the achievement was largely ignored, or even suppressed, it only served to show just how much ground the British had lost in the quest for supersonic flight. But it put in train the events that would result in Britain's first supersonic fighter, the Lightning. By 1942, there had been a number of incidents of pilots failing to pull out of dives whilst locked in combat. Some pilots did regain control and reported that the aircraft's controls had become solid whilst diving, accompanied by a severe buffeting. Initially, these reports had been dismissed as understandable confusion in the heat of battle. But as more powerful engines became available, the reports began to multiply.
At around about the end of 42, when I joined Hawkers, the Hawker Company, Chief Test Pilot George Bullman, and his supporters Ken Smith and Bill Humble, had started to investigate a phenomenon which was occurring on these big new fighters. This was loss of control and a very considerable buffeting and roughness that was experienced when they were diving these airplanes high up. It wasn't happening low down, but if they tried to get these airplanes to dive to their limiting speeds at high altitude, they were running into control difficulties.
Aerodynamic excursionists working at the Royal Aircraft Establishment at Falmouth had come to believe that the cause of this phenomenon was a change in flow characteristics over the aircraft's surfaces due to the air becoming compressed as it approached the speed of sound. Quite simply, in the thin air at high altitude, the aerodynamics of the aircraft were preventing it from going any faster. As the aircraft reached the thicker air at around 10,000 feet, the pilots were able to regain control. By 1942, the terms supersonic and compressibility were beginning to be used in discussions about these incidents. A new and apparently impenetrable limit had been reached, and fighters were now dived to their compressibility limit was part of their test program.
We at Hawkers were investigating why, and we did find during that period, and had established by about mid-1943, that if you got into this frightening lack of control, right into the point where you were actually out of control, it was rolling and diving away from you, despite everything you could do with it. If you stayed there and rode it down from 15,000 feet or so down to about 10,000 feet, the speed of the aircraft relative to the speed of sound as you got into the thicker air reduced. And as that occurred, the shock waves died down and control came back. And so this was known as compressibility. It was a recognized condition by the end of 43, and the designers were very, very busy trying to design the next generation of airplanes which would overcome this problem. But until they did, and it really wasn't until after the war that we got airplanes that would actually cope and get right through this condition. Compressibility was a limitation which all the air forces had to observe, and pilots had to be trained to avoid getting into it.
Raising the point of compressibility was only one part of the problem. The other was designing an engine powerful enough to fly even faster. Piston engines had virtually reached the limits of their potential, and so in 1942, British officials began to take a new interest in a concept dismissed by them some years earlier, Frank Whittle's jet engine. Meanwhile, Germany had also been developing a jet. However, by the last year of the war, the Luftwaffe had been beaten back to a point where its only useful role was one of air defense against the Allied bomber formations that pounded German cities by night and day. In this defensive capacity, they were helped greatly by the arrival of the Messerschmitt 262. Its rate of climb meant that it could be scrambled in time to intercept Allied bomber formations. But what came as a shock to the pilots flying fighters like the Mustang and Lake Mark Spitfires escorting bombers was the sheer speed of the Me-262. Not only was it nearly 100 miles an hour faster, it could dive significantly faster. The swept wings and jet power of the NE-262 showed that military aviation had reached a new threshold.
With relevance to the swept wing was the very high Mach number that could be achieved with it in control as opposed to any of the Allied aircraft flying at that time. I mean, it was a huge gap, a quantum jump, really.
The Germans set about their research in a way which was very effective, and by the middle of the war they were advanced very considerably in terms of aerodynamics and high speed, and they had produced a number of experimental aircraft which would get very, very close to the speed of sound. The first one that was of practical value was the Messerschmitt 262, which was a twin-engine fighter. That in 1943 was streets ahead of anything that the Allies had. It was being built and developed at the time as our Meteor, but it was a better aerodynamic concept. And it was so far advanced that the Germans were able to put it into service in 1944.
At the same time, Gloster was beginning flight trials of its E-28 prototype, which was powered by Frank Whittle's jet engine. Although the specifications had been for a research machine, it was planned to develop the aircraft into an interceptor fighter with fixed guns. The result was the Gloster Meteor. Although it was only used in defensive operations against V-1 flying bombs, the second most powerful air force in the West had entered the jet age.
The Meteor 1, 2, and 3 were inadequate, underpowered, and not effective fighter aeroplanes. The Meteor 4, with the Derwent 5 engines considerably uprated, slightly improved aerodynamics, was a better and more capable aeroplane and provided a basis for training the fighter squadrons of the Royal Air Force in the use of jet fighters. Having said that, it was never an air superiority fighter to match aeroplanes like the North American Sabre or the MiG-15, but it was for the late 1940s. It was a good step forward. It was a reliable aeroplane, and it trained the Air Force to fly formation in jets and do high-speed intercepts and so on.
There was, however, more to the beginning of the jet era than the introduction of this new and greatly increased source of power. Compressibility remained a problem, even with jet power. The challenge was now to produce designs that were aerodynamically capable of controllable flight at even higher speeds. And so the period immediately following the Second World War was one of change and excitement in aviation. The Allies lost no time in scrutinizing German research data on transonic aerodynamics. But the race to go supersonic was all but over, even before Chuck Yeager began his historic mission. The British government had cancelled the Miles M52, a research project begun in 1942, but now in its final build phase. The aim had been to design an aircraft capable of going supersonic. It had a number of design features that made it look remarkably like the Bell X-1, but there were misgivings about its potential in high places. The official reason was that the cost was too high, and besides, flying through the sound barrier would be too dangerous for the pilot.
When the news came, I was absolutely shattered. And I think we were sitting in the jet flight when we got a notice from the director telling us that the project had been cancelled. And it was as if we'd all lost a best friend. Really, I can only say we were totally crestfallen at the time. And at first, that was how it was. Then it began to boil up a little into anger. that this had been done without consulting us. We felt, as the test pilots, we should have had a say in the matter. But maybe that's asking too much.
A supersonic aeroplane had to come, and then the government, for its own reasons, cancelled. So there was an enormous sense of, well, we're losing the place. You know, we were about to lead the world, and now we're being restricted and held back. And then, of course, the following 6 months, then the Americans did it. And, of course, they went headed leaps and bounds. And we, in fact, lost about 10 years in the development of military fighter aeroplanes as a result of that decision.
Meanwhile, the RAF soldiered on with its Meteors and de Havilland Vampires, which had come into operational service in 1946. Despite its outdated design, the Meteor went on to set the world speed record in 1946 of 606 miles per hour. However, it was becoming clear that the West faced a new threat to peace from Soviet Russia and her satellites in Eastern Europe. Russia had been massively hurt by the war, and its leaders and people never wanted to have such pain inflicted on it again. For this reason, she began a program of rapid modernization of her armed forces. In particular, the Air Force benefited greatly from help given to her by her former allies. B-29 bombers, formerly belonging to the U.S. Air Force, provided the basis for a new long-range bomber force. Then Britain provided the Soviets with a batch of Rolls-Royce jet engines. Soon the Russians had a transonic jet fighter of their own, the MiG-15. Soviets' intentions became even clearer when in December 1947 they mounted a blockade of Berlin. The Iron Curtain had come down across Europe. The Cold War had begun. To compound their problems, the RAF were horrified when Australian Air Force Meteors were shot out of the skies by MiG-15s during the Korean War. However, in Britain, the Chiefs of Staff had already begun to respond to the threat. An order for the North American F-86 Sabre had been placed to fill the gaps in the country's air defenses, while new British-built swept-wing fighters were being designed. Like the Sabre, they would be capable of even greater transonic performance. At the same time, Britain's first jet bomber, the Canberra, began its flight testing. The Canberra was built by the English Electric Company, under the leadership of Chief Engineer E.W. Teddy Petter. The Canberra had been specified as a replacement for the Mosquito. However, it became clear during the design process that this aircraft would have superior performance to all of the RAF's current fighters. It was capable of flying at 55,000 feet, at almost 600 miles per hour, well beyond the range of any interceptors. Whitehall was not convinced.
In the fullness of time came the summer exercises, whereby traditionally Bomber Command would set up attacking forces coming in from the Low Countries to be intercepted by the fighter defences of this country. And it became very, very apparent that when the Canberras came in, that the Meteors weren't going to get anywhere near them. And progressively, the Canberra force was ordered to come lower and lower and lower until the Meteors could actually catch them. And they actually had to come down to about 30,000 feet before they could do that.
By 1948, the company had achieved a turnaround of opinion in Whitehall, and the go-ahead was given for a design study for a fully supersonic fighter, the P-1.
In the discussions in 1948 about the future fighter, I was asked as a chief test pilot what I felt about the practicability of flying at supersonic speeds on intercepts and in combat. And I said I didn't think there'd be any problem because it was all a question of relative speeds, and that the only thing we had to resolve was controllability, and we had to overcome the problems of compressibility and make the aeroplane fly as accurately, as smoothly and precisely at supersonic speeds as the current generations were at subsonic speed.
The P-1 evolved over a period between 1949 and 1953, against a background of hazardous research into supersonic flight. De Havilland had developed an unusual tailless design, which later became known as the Swallow. The death of Geoffrey de Havilland, whilst testing the Swallow, led to this project being cancelled, but not before John Derry became the first pilot to fly a British plane through the sound barrier, albeit in a barely controllable dive. At the same time, Supermarine had developed its 510 prototype into the Swift. Although Swifts entered operational service with the RAF, they only ever received lukewarm support. Finally, Hawker had developed its P-1052 into the Hunter. This aircraft had become the best of the series, with the ability to maintain a speed just below the speed of sound in level flight. By 1954, Hunters were replacing the North American Sabres as the RAF's frontline interceptor. Whilst these aircraft could, on occasions, pierce the sound barrier in a dive, it had become clear that this era of fighters with relatively thick wings swept at 45 degrees and high tailplanes would not produce a truly supersonic fighter.
And I think the period from 1945 to the end of the 40s was a period when the Air Force was putting up with the new jet aeroplanes, because they're jet aeroplanes, and everybody needed that sort of speed. And so these airplanes had actually outpaced the fastest piston engine fighters. Having said that, I think we would have been badly placed if a war had occurred at that time, because I don't think they would have been found to be very effective. From the 50s onwards, the Hunters came into service, which was a very, very fine subsonic fighter. The Americans had the Sabre, which was a very fine subsonic fighter, and the British started to have the Canberra, which was the world's best twin-engine jet bomber. So it all changed pattern from difficulties and mediocrity in the late 40s to getting to grips with the world's best aeroplanes by the 50s.
Petter and his team set about designing the aircraft known as the P-1, using all the experience from wartime Germany and post-war America. Firstly, the P-1 had a slim, low-drag fuselage with a nose air intake and ducts passing below the cockpit. Two Armstrong-Siddeley Sapphire axial flow engines, each capable of producing 7,000 pounds of thrust, were mounted in the central fuselage, one above the other. However, in order to avoid too much engine weight aft, the lower engine was located well forward of the upper. This layout meant that the P-1 had twice the thrust of a single engine with only around 1.5 times the frontal area. Unlike any aircraft flying at the time, it had a radical shoulder-mounted wing, swept to 60 degrees. These wings were incredibly thin but immensely strong. Finally, the configuration was completed with a thin, all-moving tailplane mounted to the bottom of the rear fuselage. In order to test this and other ideas, further specifications were issued. The first was issued to Shorts, resulting in the SB-5.
Well, it was a curious, interesting thing to fly. I mean, it had very, very underpowered. From takeoff, which was extremely lengthy, you flew it at full throttle until it was time to go home, because it wasn't going anywhere at all. It was very valuable in assessing. Well, I say it was valuable. It was effective in proving what the English electric theory. The SB-5 showed conclusively that the high tail plane with the 60-degree swept wing was a dangerous configuration from a stability point of view, and that tailplane had to be low. From our point of view, it provided a valuable little piece of development, because it was known that with these sort of sweep angles, the leading edge vortex at high angles of attack could adversely affect lateral control. As the vortex flowed over the wing, over the aileron, you could have variations in aileron effectiveness. The RAE had already identified this and were recommending to Wharton that we should have big wing fences on the P1, like the Hunter. Our aerodynamicist said, no thank you, fences are a drag, we don't want to have that. We will create a pressure fence by cutting small cord-wise slots on the leading edge of the wing in areas which were needed for inward vent valves for the fuel tanks. They put the intakes to the vent valves at the back end of these slots. And the slots, in fact, effectively transferred airflow up over the wing, controlling the vortex as you got to a high angle of attack. We tested this on the SB5. It worked like a charm. We could go from the variations in aileron effectiveness without them at high angles of attack to no variations at all with these chordwise slots. So we cut those slots in the P1 for the first flight, and they remained on the Lightning for the whole of its life. It was a good little program.
A second specification was awarded to Fairey and called for an even more radical aircraft, which would explore the possibilities of a delta wing in supersonic flight. Christened the FD-2 following Fairey's earlier experiments with this layout, the aircraft proved to be very temperamental to fly at subsonic speeds. However, the aircraft went on to set the absolute world airspeed record of 1,132 miles per hour in 1956. It was then passed over to the Bristol Aircraft Company, where it was used as a test bed for ideas that were being developed for a new supersonic transport aircraft, Concorde. Through all of this, English Electric quietly got on with developing the P1, and on the 4th of August 1954, Chief Test Pilot Roland Beaumont finally took off for a full flight.
We'd done a week of taxiing to test the brakes, test the steering, more importantly to test the drag chute, the braking parachute. And then when we'd finally got all those things working together, I'd said to the the team that we were working with, okay, I think we should do a straight, which is short for a straight hop. We're doing it on Boscombe Down deliberately, it was a long runway. I said, it feels fine to me. We've tested it to nose wheel lift. I'd like to do a straight before we commit ourselves to flying, and let's do that next time. So we then went out and did a full power run up, accelerate to nose wheel lift, which we'd established previously, held it in nose wheel lift till it accelerated another 10 knots, felt it break ground, eased the stick forward, held it parallel at probably 5 to 10 feet for 500 yards, and then eased it down. And then, so we then established that it broke ground comfortably, it was stable in flight, and more importantly, we were doing the first landing before we did the first flight. And that all is a great confidence builder, and so you knew how it was going to land. So on flight one, I'd virtually been there before, so that I was looking forward to flight one with great anticipation. And it all went according to plan in every technical way you could think of.
Then, on only its third flight on August the 11th, Beaumont took the P1 past Mach 1. Britain now had a supersonic aircraft.
So next flight was flight 3, and we planned it on the third flight as a normal professional plan to take it up to 40,000 feet, accelerate to 450 knots and see what happened on the Mach meter and how it behaved in control and stability. And somewhere around about Selseybill, going up the channel on a bright sunny day, the Mach meter went to a 9.8 as it had before, hesitated there for a very short time, then swung up to 1.02 and we were supersonic. And I took my hands off the stick, my feet off the rudder bar. The aeroplane stayed absolutely firm, no trim displacements or anything like that. Small control inputs, left stick, right stick, pitch up and down, smooth, stable responses, and we had a supersonic airplane. No vibration, no buffet, nothing at all. That was a good feeling.
Yet world events were forcing the pace of change. The Soviets had detonated their first nuclear bomb, and were now building a fleet of bombers to carry these lethal weapons. In addition, they had now developed their first supersonic fighter, the MiG-21. The Americans had developed the Sabre into the supersonic F-100 Super Sailor, and had also embarked on a program of developing a new concept in which the aircraft formed part of a Turco package combining supersonic performance with missile weapons. The RAF was intent on following. At the same time, Britain was developing a long-range jet-powered bomber force capable of delivering nuclear bombs. It was envisaged in a white paper delivered in 1957 that these V-bombers would form Britain's deterrent force. At the same time, the defense of their bases, and indeed the whole of the United Kingdom, would ultimately be entrusted to surface-to-air missiles. In the meantime, air defense lay with the all-weather Javelin.
Its limitations were that it was a short-range interceptor, again by, in my view, a very erroneous specification in the early days when we were told that this aeroplane had to be designed round a radius of action of 150 nautical miles from the V-bomber bases, as its main task was to be only to defend those bases. This limited the aeroplane enormously, and I actually went, after the first flight of the Lightning, I wrote a very positive handling report on it, and I concluded by saying, however, despite all that's gone before, we will never stand a chance of exporting this Lightning anywhere around the world until we double the internal fuel capacity.
And a ventral fairing was introduced to accommodate an extra 250 gallons of fuel. In addition, the engines had been upgraded to Avon 201s, which could provide over 14,000 pounds of thrust each, as well as having full-stage afterburn. It was these mighty engines that gave the Lightning its awesome power. They were so powerful, the pilot could literally stand the aircraft on its tail and climb vertically. A spectacle that would thrill millions of spectators around the world in years to come.
I think it's summarized by the famous pilot of Johnny Howe Squadron 74, when he was interviewed after his first flight in a Lightning, and the interviewer said, well, how did you get on your first trip with the Lightning? He said, super. I was with it all the way till I let the brakes off.
I remember I was talking to, I think it was Rowley Beaumont or Jimmy Dell, and it was at the time when they were trying to sell the aeroplane in Europe. And a test pilot from one of the European countries came over to fly a Lightning from Wharton. And they said to him, we use ordinary full power on takeoff, not reheat. Don't use reheat. And they watched him take off, and he decided he was going to use reheat. He didn't get his wheels up until he was at 28,000 feet because it ran away with him.
This, the P-1B, was essentially the aircraft that went into production in October 1958, designated the Lightning S Mark I. By now, the aircraft was equipped with twin Aden guns. Also, because it was assumed that the only role for Lightning was to shoot down attacking bombers, 2 new Firestreak air-to-air missiles were mounted on pylons low on either side of the nose. Finally, Ferranti developed a Doppler radar system in a comical center body, which was located in the circular Mohs interlink. The Lightning could now take its place as part of a weapons system, a new idea from the United States, in which the weapon-carrying fighter was the armed element of a defense system embracing long-range radar, interceptor control, and short-range, last resort, surface-to-air missiles. Later in 1958, Beaumont underlined the aircraft's potential still further by flying at Mach 2, twice the speed of sound.
And when we got up to around about 98%, we knew we were just about to get to Mach 2. And that was a jolly interesting occasion because it was a target, and it was also fascinating to see that the aeroplane was behaving just as it had been, even subsonic. It was quiet, it was smooth, it was responsive. You're looking for any errors or discrepancies. Engine instruments were fine, the temperatures were in limits. And then we got to Mach 2, and it could almost be an anticlimax because there was Mach 2 on the gauge and nothing else was happening. But then there were tests to perform, again, which could be interesting because you had to establish whether the aeroplane was still stable directionally, where it might be starting to get difficult. That was positive. Then we were running out of fuel, hauled the power back, turned it back to base, and we were descending on this lovely clear day by this time over the Lake District, having gone right round through around Dumfries and right round to Windermere in this supersonic turn. We were then subsonic and coming home with Britain's first Mark II aeroplane. So it was a good flight.
The first squadron to receive the Mark I in June 1960 was number 74, Tiger Squadron at Coltishall, under the command of Squadron Leader John Howe.
To go from subsonic to an aeroplane that was capable of Mach 2 in level flight was quite a jump. Quite a jump. And of course the introduction of a weapon system that was so more complex and effective than we'd had in the past was a big jump.
The intention was to gain experience in integrating a supersonic interceptor into Fighter Command's key Eastern Sector defense structure. The task was enormous, particularly on the ground crews, who had to keep these complex new fighters serviceable.
All new aeroplanes have teething problems, and the Lightning was no exception. As I recall, the main problem with us was electrical, one way or another. And the supply system hadn't yet caught up with this change. I mean, the introduction of a new aeroplane, new system, new parts, and everything was new. And consequently, with the aeroplane having these electronics go wrong so often, the supply wasn't keeping up. So we got a tremendous amount of help from English Electric on this, and I would ring Rowley Beaumont or Jimmy Dowell and say what had gone wrong and the part I needed, and they would say, well, yeah, come and fetch one. So we'd send a Meteor or the Hunter 7, fetch the part, get the Lightning back in the air, and we carried on like that.
Additional pressure arose from the need to display the aircraft in order to stimulate potential foreign sales. 74 were ordered to have a 4-ship display team ready to fly every day at the Farnborough Air Show in September of that year. It was a tough order, because they still didn't have 4 serviceable aircraft, at least not at the same time.
From the point of view that we couldn't get on with our operational training as we wished, but it was fun and we enjoyed it. Getting 9 airplanes in the air and having 12, the whole lot serviceable to choose from, was quite a feat on the part of the ground crew. But I worked out that to train a formation aerobatic team of 9, I only needed 3 aeroplanes, because nobody has more than 1 between him and the leader. So if they could give us 3 to train for formation aerobatics, I could work up the team, and the other aeroplanes would provide the operational training for the conversion.
74 was there, ready to impress the crowds at Farnborough. Their display established the Lightning as a firm favorite on the airshow circuit throughout the aircraft's service life. Apart from their display commitments, 74 Squadron were having to perform their role as a front-line squadron in Britain's defense. Pilots had to learn to fly the Lightning whilst maintaining an operational capability. It was a tough requirement.
And the conversion was fairly straightforward. We didn't have 2-seaters in those days, and you were taught about the systems during lectures and things like that. And then you had 10 hours on the Lightning simulator, which was a reproduction of the Lightning cockpit. So by the time you got into the air, you knew what to expect from all the instruments. And towards the end, or on your last sortie in the simulator, basically you had to try and get the aeroplane into the air because they kept giving you emergencies on the ground. And when you got into the air, you then had to try and get it back. So by the time you'd finished the simulator side of things, you really felt you could handle those sort of things. Then when you came to fly the aeroplane, that was a totally different experience. I mean, the power was just unbelievable.
To make matters even more difficult, the squadron was now taking what were termed thirst tourists. These were pilots who had never been with an operational squadron before, and who were now having to make the jump from flying subsonic jets, such as the Hunter, to Lightnings with Mark II on tap. The first flight in the Lightning was an experience a pilot never forgot.
Taxiing out, we had a system where you had to keep the electrics online. One of the engines had to be at a certain revs, only about 50%, something like that. And if you didn't use the brakes, you'd be building up to about 70 knots. And then line up with the runway, and you could just feel this power. On the brakes, open up the engines and let go, and it was just away. And I remember trying to get the nose high enough to reduce the speed to 450 knots, which was the climbing speed. At about 20,000 feet, I went supersonic. And I think a lot of people did on the first solo. But it handled beautifully. It was a super airplane to fly.
When you took off from Courteshall, you had a very rapid rate of climb, and in the radar center, there would be a light come up to warn them that an aircraft was taking off from Courteshall on a climb. I decided one day to do a timed climb to 30,000 feet. And so I put reheat in and let the brakes go and set the stopwatch going. And I was passing 12,000 feet when air traffic called me and said, check at 15, friction ahead. I immediately replied, sorry, now passing 18. And we got to 30,000 feet in 1.5 minutes in reheat.
But it was a great aircraft to fly, the last of the great sports cars, many people will tell you. It was built to fly with delightful handling characteristics. But once you were airborne, it was actually very busy because you had to fly the thing and at the same time operate the radar, the weapon system.
I really couldn't believe I was so lucky to be flying this airplane. It was a quantum leap, of course, from the Hunters that I'd been flying. Certainly, I didn't find it as difficult to fly as I perhaps imagined, in the sense that it was a fairly easy airplane to fly.
The Lightning's Achilles heel, its lack of endurance, was a constant concern, and the aircraft would have proved totally inadequate had it been necessary to reinforce RAF commands overseas. However, the technique of in-flight refueling had been perfected, aided by an availability of Valiant and Victor bombers converted to do the job. Converting the Lightnings in order to take advantage of this capability was fraught with difficulties. Firstly, there was the question of where to put the probe.
When we first saw the probe mocked up in the mock-up at Wharton for the Lightning, the probe or the Lightning, I couldn't believe what I was seeing. This was one of the few occasions when there hadn't been direct coordination between the design department and the flight department, where normally all flying matters, there was sort of interchange of views. And the probe, I looked at this thing from the cockpit of the mock-up, and the probe head was behind my shoulder. And I thought, how the hell am I going to steer that into a drogue that's coming down like that? And I pointed this out to the designers. They said, oh, well, nobody's objected before. So I said, well, I'm objecting now. They said, too late, we've already issued the drawings. So I said, well, you're going to have to change the drawings, aren't you? And we had a hell of a row about that, and eventually got it extended forward so you could see the probe head in the windscreen where it ought to be.
Refueling initially, it was tricky. I don't know whether you've seen the refueling probe on a Lightning, which was very much an afterthought, and like many other things. But it was relatively tricky initially, but rather like riding a bicycle. Once you've got the act, it becomes fairly second nature. And certainly if you do a lot of it, when you're doing it sort of on a regular basis, then the problem tends to go away. The problems with the original flight refueling of the Lightning was that we were refueling against the Valiant tanker first of all, and then the Vulcan, which had only at that stage a centerline probe and drogue. Sorry, not a centerline probe, a centerline drogue with a big basket, which of course was effectively designed to refuel other V-bombers. So you had this enormous basket into which you stuck your little Lightning probe, and if there was anything of a wiggle on this hose, it would just literally whip the end off your probe, and that was it.
Progressive development continued, resulting in the Mark II in July 1962, with fully variable afterburning avons, as well as an autopilot and steerable nose wheel. This was followed by the Mark III. The Lightning F3 marked a major turning point in the Lightning's development. Firstly, it had a broader, more angular fin, flattened at the top. It also had a kinked and cambered wing edge, which was flatter at the end than before. But perhaps even more significantly, the Lightning F3 had no guns. The Firestreak air-to-air missile had been developed so that it was now fully integrated into the aircraft's guidance systems.
Big mistake to drop the guns. I think every fighter pilot would tell you to drop guns from a fighter airplane, yes. And certainly we all felt that was a big mistake. And of course it was redressed when the Mark VI came into service and they put them in the pack. But again, it was a problem of space in the aeroplane. If you put a bigger weapon system in, a bigger radar with lot more black boxes, there just isn't room for guns, and that was the problem, I suspect.
This was the era of QRA, or Quick Reaction Alert. This meant that aircraft and pilots were kept in a state of readiness, so that should intruders be spotted, the Lightnings could be scrambled to intercept them.
Our role was to intercept far enough out over the North Sea, basically high or low level, to prevent them from firing missiles at us. That did not require long range. What we had to be able to do is react quickly, get out there fast, fire, get back, turn around and out, and back and out and back.
The Lightning Force was much better looked after in the sense that we did most of our QRA from crew room readiness initially, and then eventually, of course, they built the QRA sheds where you were very well looked after. The aircraft was covered, catered for. You had sleeping facilities, so it became quite a pleasant environment. In that, if you can call sitting QRA a pleasant environment, because of course, for quite a lot for the time you're on QRA, you're dressed in your flying kit. And when you're wearing an immersion suit, that wearing it for a lengthy period, it becomes fairly exhausting.
We sat QRA, quick reaction alerts, periodically, and the aim there was that from getting the scramble order, whether you were relaxing in the crew room, say, or asleep at night, 10 minutes later you could be airborne. And that could be done. There was no doubt about that. The aircraft, the longest thing was getting into your kit, so you kept your kit on, and then you ran out to the aircraft, pressed a button, the hangar doors opened, front and back, you jumped into the jet, and 2 buttons, and you were started.
74 Squadron was now based up at Lucas, responsible for patrolling the vast areas of the North Sea, particularly the vital gap between Western Scotland and Greenland. In 1966, 74 Squadron replaced its F-3s with the new F-6. Firstly, the pilots got their machine guns back, for the F-6 could carry combinations of armaments in special packs. The new aircraft had a much enlarged ventral pack, which contained a fuel tank holding 610 gallons. There was also an option to carry 2 overwing tanks, each containing a further 250 gallons. They had to be mounted on top of the wings because there was no room underneath for the tanks and the undercarriage. These refinements, coupled with an enlarged wing, meant that the Lightning's abysmal range was increased by 20%. For 74 Squadron, this was particularly important, for in June 1967, the squadron left for Tenga, Singapore. The leg from Cyprus to Mazara proved to be particularly hazardous, as their route took them over Turkey and Iran.
I flew the same aeroplane all the way from the UK to Singapore, simply because the thing was unserviceable the whole way from UK to Singapore. I think it was my starboard wing that the tanks never fed. The fuel I took had the same fuel when I arrived in Singapore as I left Lucas with. And so the aeroplane was basically unserviceable the whole way. And what I had to do, of course, was to do considerably more flight refuelings, which the tanker force were well able to cope with on the way there, just to get the airplanes out there. And we arrived, from memory, we arrived on the right day about 30 minutes later than actually planned 6 months before. So I got there with my 3 airplanes virtually on time. And that to me was a tribute to the success of the planning, particularly by the tanker force.
Throughout this period, Lightning squadrons continued to display their aircraft around the world. But it was not until 1966 that the sales effort began to show results.
What we had to do was to explain to the Saudi Arabians that if they bought a Lightning with all its enormous capability, it wouldn't be the Lightning that the Air Force was restricted with, which was the Mark VI, but that it would have additional capabilities of reconnaissance, up to supersonic speed reconnaissance, underwing stores, rockets or bombs, 2-inch rockets. It was a multi-role airplane, and overwing tanks as well. We had done all of these things separately. Now we were going to bring them all together, except for the Vinton camera pod, if the Saudis wanted it. They came over and they did an evaluation. They said, we will not entertain thoughts of having your airplane until our test pilot tests it, you see. And they sent the chap over by the name of Captain Hamdan and said, we will fly your Lightning. And we said, okay, fine. What experience has he had? And they said, he's current on Sabres. And I said, yes, well, that's all right. A Sabre pilot could convert onto a Lightning with some dual. There won't be time for that, the Saudi authorities said. He'd do one dual flight and then one solo flight in the Lightning. And during that solo flight in the Lightning, he must go to Mark II. So this was a chap who was going to do his first solo flight on a Lightning and go to Mark II on one flight. I mean, it throws the Lightning conversion unit at Coltishore and things into complete disarray, a thought like that.
The Lightnings exported to Saudi Arabia and Kuwait were variants of the Mark VI, but with ground attack capability, as well as versions of the 2-seater T5. The F-6 was to be the last totally British-built supersonic aircraft, for in 1966 an order had been placed for the McDonnell Douglas F-4 Phantom. Whilst the aircraft's design was already 14 years old, it was well proven in combat in Vietnam. It was while locked in combat with the North Vietnamese MiG-21s that the American pilots learned the value of a machine gun.
Well, for conventional fighter pilots, they couldn't see the point of a fighter without guns, because they felt that it was most likely that you'd come up against other fighters. And because an air-to-air missile in those days required space to align and lock on and all the rest of it, you could be in a situation where you would be firing against other fighters who had guns and you didn't, and you were therefore at a disadvantage. I can see the missile was wonderful for air defense, but not air-to-air combat.
The MiG-21, which was in many respects a Russian Lightning, was far more maneuverable and could turn in tight enough to shake off the missile. The defenseless Phantoms made easy targets. The Americans soon learned their lesson, and Phantoms were subsequently fitted with guns. But would the Lightning have made a good dogfighter?
Yes, the Lightning was a very good dogfighter. It had the power. It had the ability to turn very, very sharply. It could accelerate. It really was, I thought, a good dogfighter, yeah.
The Phantoms, however, had a more advanced radar system that enabled the pilot to look down as well as forward. But it now required 2 crewmen to manage all its systems. In order to get the most out of its fighter force, the RAF began to experiment with a new concept, the mixed fighter force. The strategy was for the Phantoms to use their look-down capability to seek out bomber formations or ground targets, while the Lightning was used their look-forward window to seek out Interceptor. As both aircraft had similar performance, the combination worked well, but their days were numbering.
We were complementary. I think each aircraft is complementary to another, and the requirement effectively is to use the force in the best possible way, either by operating them together or in a combined sense if you can. And towards the end of my time at Binbrook, then we got into the mixed fighter force, because at the time they were introducing the Hawk, which was the jet trainer, it had no, if you like, no radar capability at all, so it needed to be led into the fight or led into the bomber stream, although it had a weapons capability. And again, the Air Force was reducing in size, so the numbers of airplanes going down, so the Air Force felt and found that it needed to use every available airplane that it could. So you now get into the area of trying to operate various types of airplanes together, and that's where the mixed fighter force came in. And the original intention was that we would all, Lightnings, Phantoms and Hawks, would effectively all go together towards the bomber to the cap points, and then, if you like, not do our own thing from there, but then a radar equipped airplane would take a Hawk into the bomber stream. So we would arrive at the point and then go into the bomber stream, and then once you're in the bomber stream, then you're on your own, effectively.
The Lightning was only supposed to have a service life of 8 years, and as early as the mid-60s, plans had been put in motion to find a long-term replacement. Given the enormous cost of developing supersonic aircraft, Britain was forced to find partners. The Lightning, however, soldiered on until 1988, when numbers 5 and 11 squadrons traded in their Lightnings for Tornado F-3s, 40 years after the original Lightning had been formulated. The Lightning, which was created at the beginning of the Cold War, had survived to witness its conclusion. Today, the Lightning is remembered for its blistering performance, a performance that even some of the most advanced fighters in the world cannot match. Yet the Lightning set more benchmarks in aircraft design than speed alone.
Highly swept wings, low tailplanes. They've all got them. You have a look round all the jets, the exotic Russians, F-16, F-15, excluding the French, which is another matter, the EF-2000, they all have swept wings, low tailplane. And that is a legacy of the Lightning. The Lightning started the fashion, and that's the way they'll always be. Unless you go to a pure Delta.
I think that we had hoped that we would go through the sound barrier in level flight as opposed to a screaming dive downhill. I mean, the Hunter could go through the sound barrier downhill, and the American similarly in their Sabre, etc. But to go through it in level flight, that is an achievement. And it was certainly at that time. And I think it made every Briton proud, every man that was involved in aviation anyway. Oh no, I think the Lightning is a nice little milestone in our aviation history.
I think the legacy of the Lightning, as far as our Royal Air Force is concerned, is that it did bring technology to the forefront of the people that had to fly it, service it, operate it, control it in the Sector Operations Centre. It was a high-tech beastie for its time, and luckily our very senior officers now, both aircrew and engineers, were brought up with that concept. So I think it probably made our Air Force much more, or helped to make us technology conscious rather than frightened of technology. That's just my view.
I would have thought that certainly in terms of recognition that you need an aeroplane with a dogfighting capability or an air combat capability, that's been seen to be a continuing requirement, and we're now into Eurofighter, because with the, if you like, the Phantom and then the Tornado F3, I haven't operated the Tornado F3, know very little about it, but reputedly it doesn't have, it wasn't designed, doesn't have that sort of capability. Also, the need, if you like, for the supersonic dash is still seen to be there, and aerodynamically, I'm sure the Lightning contributed to that.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.
Lightning was just phenomenal in the 60s. Its aerodynamic performance is comparable to any of them today. It had a 1-to-1 power-weight ratio, 36,000 pounds of thrust, could climb vertically, could go supersonic on one engine, could sit happily at one engine at 40,000 feet, You know, its aerodynamic performance was just stunning. All the fighters of those days, the 104 Starfighters, the G91s, and others of the NATO nations, would all come and try and attack you. And of course, generally they were gun armed, so they had to get into 300 yards on you. Well, you'll be sitting at 36,000 feet, watch them come up through about 20, 25, and then fall out of the sky, wave at them, and then you could turn in behind and shoot them. So it was a tremendous machine, and as a youngster, you just felt invincible. There was nothing could touch you. The only problem was, of course, and the only thing that would touch you, was if you ran out of fuel, and it used to gobble the fuel up at a phenomenal rate. If we were doing a 1v1 combat where you were in reheat for pretty much it, you'd get airborne, go 20 miles, get to the area, inwards turn for combat go, select full power, you could get rid of it all in 10 minutes. So, and 10 minutes in 1v1 combat flashes by. It just goes in an instant. So you really, really had to watch your fuel. And that was a big issue with it. It didn't go very far, and when you got there, it didn't stay a very long time. So as a modern day fighter, of course, although the aerodynamics is comparable, it wouldn't hold up. We were based in Gütersloh in Germany. We were the first line of defence. There were 2 squadrons there. And then we had 1, 2, 3, 4, 5, 8 more squadrons back here in the UK, down the east coast of UK, and the Cold War was at its height, and we believed that the Russians and the satellites, you know, Poland, East Germany, Czech, Slovakia, and the other countries, would attack us first, use up our first line of defence, so we'd all scramble and shoot them down, or them us. We would then have to land and refuel, and at that point we believed that the Russian Air Force would take over while the satellites were refueling, and they themselves would come and attack us. So it was very real, and we were 35 miles from the border. They could be with us well within, you know, five minutes of a warning, which is why we held alert out there at 5 minutes. We had to get airborne in less than 5 minutes, which we did every day. Every day we practiced from the alert sheds, scrambling both aircraft at separate times to make sure we got airborne in less than 5 minutes. The reason we were there was mainly to attack, I think, their fighter bombers. They were going to send fighter bombers over to take out our radars, I imagine, and then to take out our airfields. They wouldn't be long-range strategic bombers. They would be tactical fighter bombers. And, you know, we were there to counter that threat. The long-range tactical bombers were, bombers were more for UK orientated, and they'd probably come around the North Cape or across Scandinavia. But in Central Europe, we were very worried about the tactical bombers. They had fighter bombers, and that's what we were there to counter. Maintenance and spares were a problem. As I say, it was a test bed. It developed from a test bed. It was never really designed as a fighter aeroplane. So it was very hard work for the ground crew. And when they went unserviceable, they were sometimes extremely difficult to fix. And spares, as always, were in short supply on every air force in every nation. There were never enough spares. So at times, there were very few aircraft on the squadron that were actually serviceable. You know, they would remain unserviceable for long periods of time. Well, the Lightning came into being because it was decided we needed a supersonic fighter. All aircraft fighters up until then in the RAF had been subsonic, from the Hunter to the Javelin, Sabres before that, and so on. Nothing supersonic, or not a genuine supersonic fighter. And so the Lightning was devised, and it came about from a British Aircraft Corporation test bed where they were testing engines for supersonic flight. And you may remember it's one engine above the other, strange configuration. They stuck a cockpit at the front of it, did various modifications to it, and produced the Lightning. The one thing that it had above all other was phenomenal power. It was an engine test bed, and therefore the engines were pretty good, Rolls-Royce. Produced 36,000 pounds of thrust, and it only weighed 36, so it was a 1-to-1 power-weight ratio. First aircraft that could do a vertical climb from takeoff. And we used to practice them on the conversion unit. You were allowed to do a rotation takeoff on trip, I don't know, trip 9 or 10. Here, lad, go and do a rotation. So you'll be carefully briefed on this pretty aerodynamically dangerous manoeuvre, if I stop to think about it, although it was okay. But so you were briefed, you went out, you're a young lad, end of the runway, up to full power, reheat, get airborne, and there was a trick to get the undercarriage up very quickly. Because the nose wheel came up forwards, so as you lifted off, it came forwards. Now, if you got too fast, the airflow held it down and it wouldn't come up, and therefore you had to slow down, so your rotation had to be cancelled. But assuming you were quick enough to get the gear up, nose wheel locked up, and as soon as it locked up, you were now at about 230 knots, slight pause, check you were at 250 knots, and then literally just pull the stick back into your gut as hard as you possibly could. And this aeroplane would then just rotate through 90 degrees and continue going upwards. It was a most extraordinary sensation. For a young chap, you then had to worry about what happened when you ran out of speed at the top, but they didn't tell you much about it in those days. Well, I remember that really the height of the Cold War. This would have been 1969 or 70. And it was in the days when all the bases had regular call-outs, the hooter would go. And at any time, the day, night or weekend. And when the hooter went, you dropped whatever you were doing, rushed into the squadron, changed into your combat kit, reported for the briefing, and on you went. And there were two types of exercise. One was a generation exercise whereby the ground crew loaded the jets with live weapons, and the other were flying exercises where you did not load them with live weapons, but you flew instead. And occasionally, in the early days, the two did combine. So you might well go in thinking it was a generation exercise where the ground crew loaded all the jets. You would go out and check them in, of course, and sometimes you would actually be scrambled. So there you were getting airborne in an aircraft with live weapons on, which was quite safe. It was all right. Anyway, this particular day, it was a Friday evening. I can't remember whether they had a dining-in night or it was just a night in the bar. Anyway, the squadron was well oiled when the hooter went. So we rushed in to, get changed, as we did. We'd all had a lot to drink. And we were all thinking, I hope this is a practice, because you never knew when it went whether it was for real or not. So you did sober up pretty quickly, thinking, gosh, it's good, because Gütersloh, where I was at the time, was only 35 miles from the East German border. So if the Russian hordes were coming, it didn't take them long to get there. So we did react quickly. So anyway, rush into our jets. We're all allocated jets, so we get the briefing and out we go, check them all in, and we're all sat there. And I remember for some reason there were about 12 of us. All the jets were generated, and we were all in there. We checked in one after the other, and we were all there. And then a voice came on the RT, and it was our boss, who had a broad Scots accent, and it went click. And he said, "Nobody from 92 Squadron is to get airborne. Do I make myself clear?" Click. So we knew at that point that this was obviously just a training exercise. But even if it was a training exercise, he wasn't having any of us get airborne in any of his jets, because we'd all had a skinful. So that was early on in the early days.
Aviation, the art of aeronautics, began with the dreamers, inventors and daredevils who dared to defy gravity. The journey of aviation was nurtured by pioneers like the Wright brothers, whose first flight marked a historic milestone. The role of aircrafts in world wars was groundbreaking, dramatically changing warfare strategies. This initiated a technological evolution in aviation, transforming the simplistic wings of a biplane into the thunderous roar of jet engines. Let's journey through the ages of aviation. Behind every great aircraft, there were great minds. These visionaries, like Sir Frank Whittle, the innovator of the turbojet engine, redefined air travel. Then there's Skunkworks' Kelly Johnson, the genius behind the SR-71 Blackbird. His designs combined speed, stealth and power, crafting machines that dominated the heavens. The contributions of these pioneers have left an indelible mark on the canvas of aviation, shaping the course of history and inspiring generations of engineers and aviators. Each epoch in aviation history gave birth to extraordinary aircrafts, each with their own unique features and roles. The Lockheed SR-71 Blackbird was a marvel of speed and stealth. The F-105 Thunderchief, a supersonic fighter bomber, was vital in the Vietnam War. The P-51 Mustang, a long-range fighter, was critical in World War II. The P-47 Thunderbolt, a heavyweight fighter, was used extensively in the same war. The A-10 Thunderbolt II, the Warthog, is a close air support icon. The Messerschmitt Me-262 marked a leap forward in aviation technology. Each of these game changers were instrumental in their eras, and their legacies still resonate today. Beyond the game changers, there are those that have transcended their practical roles to become icons. The Concorde was not just an aircraft, it was a supersonic symbol of luxury and speed. The B-52 Stratofortress, a strategic bomber, is an icon of power and resilience. These magnificent machines and others like them have become much more than just aircrafts. They are enduring icons that encapsulate the audacious spirit, the relentless innovation, and the boundless ambition that define the world of aviation. For more amazing aerial footage, and to join us in this incredible journey, check out the DroneScapes YouTube channel.
If you enjoyed this video, please remember to like and subscribe. And as always, thank you for watching.